Okay, on Friday functions, we went ahead and we went over some of those progressing level skills that we did at the beginning of this unit. So I want to go over this one more time. So, just as a reminder, the initial side is always going to be where the x-axis is positive. That is going to be our starting point always. We're always going to start there, whether the angle is negative or positive. Now, we're going to use those quadrantal angles to help us decide where an angle ends. So if we are doing, I don't know, we'll do negative 355 degrees, I'm going to start here and I'm going to work my way down. I'm going to go negative 90, negative 180, negative 270, and about right there is going to be about negative 355 degrees. So if I draw that right there, I'm going to draw my ray. This is not as easy as it looks, so I'm going to try again. Oops. Switch screens. Okay, I'll draw my ray. It's going to be about right there. Okay, so I have my negative 355 degrees. If I was looking for a positive coterminal angle, now remember, coterminal angles are angles that have the same ray. So if I'm looking for a positive one between 0 and 360 degrees, so smaller, the smallest possible one, I would go from here to here. Well, to go from there to there, that would only be 5 degrees. So negative 355 degrees and 5 degrees, those two angles are coterminal because they share the same ray. I could do here, I'll do a different color. So let's see if I could do, let's say, another angle that is even larger. So, okay, let's see if I can change this color. It should be, let's see. There we go. Let's do positive 1085. So, 1085 degrees. Okay, so I'm going to start here at the starting point. If I go all the way around, I'm at 360, all the way around again. I'm at 720, all the way around again. This right here is 1080. If I go up 5 more degrees, I'm going to end on that same ray, and I have that. But I went around three whole times plus a little bit. So these are all coterminal angles because they share the same ray. They all start and stop in the same place. We just might go around one direction or the other direction. So we went over that. We went over being able to find an exact number. So I gave out a worksheet that looks like this. Let me get it. Where you were finding the 6 trigonomic functions with the exact values. And the triangle that we're looking at is a triangle that has an angle x. So x is up here. This is a right angle. This side length is 15, and this side length is 7. So to find this one, we need to do 7 squared plus, I'm going to call it b squared, is equal to 15 squared. So we get 49 plus b squared is equal to 225. We subtract 49 from both sides, and we get b squared is equal to 176. Take the square root, take the square root. We need to simplify the square root, and we need to leave it in radical form because we want an exact number, not a decimal approximation. So that actually is going to equal the square root of 16 times the square root of 11. Well, the square root of 16 is 4, square root of 11. So this side is actually 4 times the square root of 11. Okay, so then you're going to answer all 6 trig functions. So if I were doing the first one, the sine of x is going to be equal to, so this is the angle x, the opposite side, which is 7, over the hypotenuse, which is 15. Okay, so you're going to do the same thing with that. Cosine would be adjacent, so you're going to get the square root of, 4 times the square root of 11 over 15, and so forth. Remember that when you have, so if we were to do secant, so secant would be 15 over 4 times the square root of 11. We need to get that square root of 11 out of there, so we're going to multiply both sides by that, and we're going to get 15 times the square root of 11. 4 times the square root of 11 squared is 4 times 11, so we end up with 44. Okay, so if you have any questions, please let me know. Otherwise, I hope you all have a great day, and I will see you next time.